minutes ago. And can we go back to the shake map? Where is it? Okay, here. Notice that there's red areas. That's implying a quite high shaking intensity. Intensity is different than magnitude. There's one number to represent the size of the earthquake. Yesterday, the biggest was a 6.4. Today, the biggest is a 7.1. Intensity is what you feel. So we have here a map of what the shaking intensities were up around the Ridgecrest area. Notice that they are going into red. That is intensity 9. The 6.4, we only got up into orange. Intensity 8 had been the maximum. So this was definitely stronger shaking, and unfortunately it looks to be pretty high levels of shaking there in Ridgecrest. 4.6, okay.
How far was this from the main shock district?
Huh?
All right, so remember, earthquakes don't happen at points, so, all right, they're planes. The 6.4 actually seemed to have happened on 2 planes. All right, let's go back to the, yeah, thanks. Oh, hard to see it now, isn't it? Yeah. Okay. There's a northwest striking surface, and there is a southwest striking surface.
This one, as
what we can tell at this point, it looks like it happened on the northwest striking feature, because we saw several. Notice the red boxes, the up at the northwest corner of the big box. That's showing us aftershocks happening northwest of the main shock, and that implies that's the direction that the fault went. Here we're seeing it a little.
2%.
We're still struggling to get up with a good figure.
Right. The epicenter of the 7.1 in relation to
is 6.4. Okay. The epicenter of the 7.1 is at the northwest end of the fault that moved in the 6.4. Now the 5.4 aftershock this morning extended that fault. What we saw from the main shock, from the 6.4, the 5.4 extended it a bit to the northwest, and the 7.1 seems to have extended it even farther to the northwest. So the fault is growing. We ruptured a piece in the first earthquake. We ruptured a bit more in the 5.4 this morning, and we're rupturing more now. It is moving towards the northwest, away from the metropolitan area, as far as we can tell.
And a 5% chance this will go even further.
Right. This is another earthquake. Everyone has a chance. I'm trying to think if we've ever seen a situation with a 6.4 or 7 and then something even bigger, and I can't think of one. Not that it isn't possible, but I can't give you an example where it's happened before. We've had foreshocks to a lot of other earthquakes. The Landers earthquake, which is a 7.3. 2 months earlier, there was a 6.1 called the Joshua Tree earthquake. That's far enough apart that we don't usually use the word foreshock. We call it a pre-shock. There was a 3.8 a couple of hours before the 7.3. In 1987, the Superstition Hills earthquake, 6.6, was preceded the day before by a 6.2. So that's why we keep on saying 1 in 20 chance. Well, this is the 20. The 1.
Can you talk about the 6.4 yesterday and how it relates to the 7.1? Which was the main quake, which is the...
Okay. By definition, because the 7.1 is the largest, we give it the name main shock. So yesterday or an hour ago, we were calling the 6.4
Because Rebecca said everybody and their mother's contacting her because it's like, oh, contact the geologist.
And so we changed the name.
That's right. We don't just look at rocks, people.
Foreshock, and that really large aftershock has become the main shock. As far as we can tell, those names, foreshock, main shock, aftershock, are semantic. There are tools for trying to describe what's going on, but when you have a sequence going on, every earthquake makes another earthquake more likely, and that's what we're seeing right here.
And you're already having aftershocks. Can you talk about how many, how big?
Well, all right, so just look right down here on the lower part. Since the 7.1, we are only seeing basically the 4s and 5s showing up. We've had 1, 2, 3... about 10.
It's 5.7.
Oh, 5.7. Okay, so we have an earthquake that's already begun up north, just slightly to the northwest of the main shock. Our early warning system is saying 5.7 with 26 seconds till it gets here.
We're probably going to feel it here in a second.
A 4.9 we felt. So this, assuming that the magnitude isn't really misestimated, my guess will be we'll feel this as it comes through. In about 12.
10
And
seconds.
do we expect this magnitude of aftershocks throughout the rest of the evening?
Well, yeah, the largest aftershock is likely to be a 6.
Wait, here we go.
We should be feeling it now.
Hmm?
Very,
There it is.
There it is.
There it is.
feel it?
Oh, something.
Yeah.
That was the phone ring.
That was less than I felt from the one that was labeled as 4.9. So,
You can tell it happened because
all right.
The blinds
So clearly we're a
and-
long ways away from the earthquake. We're still, can we feel it? Remember that the people in Ridgecrest are going through a lot worse than
Yeah,
this.
they got
We
it way
already
bad.
had damaged
Worse
houses
than us.
and structure fires out of the first earthquake. This is going to have been more intense shaking. Okay. This came through just as a 3.5.
And Lucy,
Yeah,
this is
it
all on the
Yeah,
same fault
her
line
watch
as the
probably
6.4?
updates her.
Yes, the same fault system.
Smart
It does
watch.
appear
Yeah,
to
that's
have
an Apple
multiple
Watch.
strands to it. We've already seen the 2 perpendicular ones. I think it got the magnitude wrong, because, yeah, unless it hasn't come through yet. So,
Dr. Jones, can you explain the shake alert again? Because some people just got the initial report that it, quote unquote, wasn't working.
okay,
Explain again that.
there. Let's let the USGS handle that one.
So the system worked.
Oh, that was a 5.1.
Yeah.
Okay.
Yeah. So the Shake Alert system worked both on the USGS side and on the Shake Alert LA side. The reason why alerts or notifications didn't go out to LA County is that the threshold for shaking was set above what the estimated shaking would be. So it was just the way that the system was designed. And in fact, the same thing happened again tonight. My understanding, the alerts did not go out on Shake Alert LA. A magnitude that was estimated with a early warning system was 6.2. So the initial magnitude estimate was too low.
I'd probably start keeping your
Consequently,
slippers on
the
your side of your
intensities
bed,
were
though.
below that threshold. So the system is not perfect, but again, what was experienced here in Pasadena, LA area, these were not damaging ground motions. What's going on up in Ridgecrest, those are damaging ground motions. So those folks are really feeling it.
Robert, what's the chance of another large quake like this or even larger tonight?
Well, as Dr. Jones had said, there's a 5% chance that this could be followed by an even larger quake. And well,
That's the number of 5% is usually for a few days. The most likely time is within a day, which is what, of course, we just saw, 30 hours or something, 36 hours.
yeah, and in fact,
Earlier that you don't recall any seismic earthquake sequence where the 7.1 was followed by a greater earthquake.
Oh, no, I just don't remember one that's had this in California that's had that series. There are places elsewhere in the world. There was a magnitude 8.5 that was a foreshock to a 9.5 in Chile. So there is nothing about the magnitude that says it can't be a foreshock.
Right, but in California, along this, in the seismicity of this state, you've never seen anything follow a 7 at all.
boy. Yeah, but that doesn't mean...
We haven't, no, we have in Nevada. We have in Nevada the
Yeah.
Fairfield earthquakes.
Yeah. Yeah. The takeaway here, though, is that as we have just seen between yesterday and today, quakes that we say are main shocks can actually be foreshocks to larger quakes. So,
And we won't know till it does or doesn't happen.
yeah, there's a small percentage.
On the same depth, for the most part, as the 6.4?
Yeah, well, it's 17 kilometers.
Yeah, so it's the epicenter is a little bit deeper. We do have geologists out in the field. We haven't got reports back, but they'll be able to go out and
But
document.
also remember,
You said 5 to 10 miles?
so that's the 10 miles,
10.
right? It's 10 miles down, whereas the one yesterday was more like 6 or 7 miles down. However, a bigger earthquake also involves a larger fault, so it still may very well. Probably this is coming to the surface.
Is there...
What you're really worried about is, are we going to trigger something outside of this region?
Right.
Probably not. Okay.
Why?
because we're too far away. The ability to trigger another earthquake is very spatially defined. So the most likely place to trigger it is on the same fault. As you go away with distance, it becomes much less likely.
How far is that from the San Andreas?
It's quite a way.
Quite a ways.
At
It's not even on that figure.
60, 80
it's
miles.
over 100 miles to the
Yeah.
San Andreas from this location.
And the Garlock?
The Garlock fault is a lot closer.
Yeah.
And the Garlock fault is another long fault. If we were going to be triggering something really big, the Garlock might be a source for it. This is sort of like when landers happened near the San Andreas. And we said, oh, if we're going to set off something bigger, there's only the San Andreas around. Of course, it didn't happen. But it was a possibility, a low probability possibility. The Garlock, luckily, really runs through some of the most isolated parts of California.
You said yesterday there were two faults making this L pattern, so there was that lower little leg.
Right.
Now the top
Conjugate faulting.
It's the northwest part that's extended and grown, whereas the southwest striking one doesn't seem to have had more earthquakes.
Is that a surprise at all to you that this fault system was capable of this kind of earthquake?
No. There was a magnitude 7.5 in 1872 in the Owens Valley. There have been lots of 6s. There's this whole series. When I said Nevada, 1915 and 1954, and I don't have the magnitudes in my head this time, but they were 7s. There were series of earthquakes with several events within them of 6 to 7. In Mammoth in 1980, there were 4 magnitude 6.5s that happened in one sequence over about 10 days. This part of California is characterized by these type of groups of earthquakes that there might be several that end up larger. The first one is often not the biggest one. Knowing that which one is the biggest one means waiting till we see that we aren't getting another one.
When was the last time we had something sizable in Garland?
Not in the historic record. Prehistoric.
This is extending about 25 miles, you said earlier?
That's an approximate guess off of looking at these figures, which are having trouble coming up.
The northwestern fault, is that the one that's moving into China Lake?
The southwest striking one is the one that goes sort of from China Lake down to Ridgecrest. The northwest is going up through the China Lake Navy base.
I know that there has been trouble trying to get geologists onto base. Have you guys made any progress on that?
Yeah.
Yeah, actually, our geologists have contacted the Navy and are able to get on the base with some limited access. Now, that was prior to tonight's event. So presumably, I would expect that there may be further damage on the naval base. We don't know yet. I haven't gotten reports, but my suspicion is that the geologists are going to be able to get out there very quickly and look at potential rupture. The other comment here, just following on what Dr. Jones was saying, when we have events that where a main shock then becomes a foreshock, typically the triggering is relatively close, and that's actually what we saw here. These two earthquakes are relatively closely located, so the triggering typically does not happen at a great distance. More typically, it's close by.
I can't think of any example where we've seen this type of foreshock triggering that isn't within just a matter of a few kilometers. I mean, the famous widespread one was Elmore Ranch and Superstition Hills, a 6.2 that was on a southwest striking fault and then set off a 6.6 on a northwest striking fault, sort of like this. The epicenter of Elmore Ranch was up here, but the fault extended right down to the Superstition Hills. And we were seeing aftershocks pounding at the Superstition Hills fault up until the time that the earthquake happened, the main shock happened. And we've got a similar situation here where we've had aftershocks along this fault. And then we had the 5.4 breaking through a bit towards the northwest, and now we've had it again. And we now see more aftershocks up to the very northwest end, and chances are we stop now. It's possible that we'll continue to extend up to the northwest.
Right. You said for a 7.1 magnitude quake, you could expect an aftershock sequence that lasts for over a year.
Yes. All right, so the 7.3 Landers earthquake, the last magnitude 5 to that 1992 earthquake happened in 1998, so 6 years after the main shock. We should be expecting to record earthquakes here for a long time.
Can you describe that terrain where this aftershock was, or where this main shock was?
Well, the terrain is very isolated. It's desert, not a lot of population. So actually, in a sense, for being able to get people out there and look at it, there's a good opportunity. And also because it's not densely populated, the chance of having damage to structures and injuries is much lower. But it is still very, it's hard rock. These are faults that are breaking through hard rock. That's why they create these waves that we feel strongly, even down here in Los Angeles. There we go. Now we got
one more, actually. Can we do?
Yeah, we're now getting some of our graphics up. So,
Okay.
Lucy, if you want to describe this, and I can kind of point and
Right. So the blue means it happened more than an hour ago, but less than 24 hours ago. You can actually see some yellow underneath because we're more than 24 hours since the main shock. But all those blue dots are the aftershocks over the last 24 hours.
You can see the fault patterns.
The red ones are within the last hour. So the main
See all the
shock
little
has
hash
already
marks?
turned blue.
Those are all different fault lines,
And that's right there.
fault boundaries that USGS knows of.
The epicenter of the 6.4 was basically at that corner, and we think ruptured.
And you can see the fault down to the
clearly
south,
ruptured to the southwest,
east.
probably also some ruptured to the northwest.
Essentially, anywhere there's
in the same
mountain
event,
ranges, there's going
maybe
to be
in the
fault lines along the
aftershocks
base of
afterwards.
them.
Then the 5.4 aftershock was. The one this morning was located right in there, moved the fault a little farther. Then we have the 7. And now look at that cluster up to the northwest. We think, right now we aren't getting many of our aftershocks recording yet. The system's pretty strung out. And so we're pretty sure that is a continuous aftershock zone. And that would mean that's the extent of the fault.
yeah. So
And just the length of the fault, a magnitude 7.1, we would expect that it's probably at least about 25 miles long. And that would imply probably that whole length from where the 6.4 happened up to where those aftershocks are up in the corner.
That says China Lake up there.
This is,
Yeah, so the
okay.
naval.
Oh, yeah. All right. The Naval Air Station is that whole area. So this is all within the Naval Air Station. There's a fault system. So we see all these little faults on the ground. Rather than naming each little piece separately, it's been called the Little Lake Fault System. And so that's, these are...
So the length of the fault itself has been defined by the 7.1 earthquake?
No, we don't know.
You don't know.
Right, and if you look at the mapping that we can see there, and one of the things we can do if we got a bit of a break and found some stuff, we could pull out, we'll try to get out the state geology map and really see the detailed mapping that's been done in here beforehand. But notice that there's this little string of, you see where the cursor's showing you all those little faults going up to the northwest. And it was not mapped as a through-going fault. It was little pieces up through here, and now we have more little pieces farther up. So, no, we can't say, the fault's used up. It would, but most likely, if we were to see more going on, I would think it more likely that we're heading to the northwest than turning around and coming to the south again.
So the surface rupture, how close would that be to the epicenter? I mean, are they tied together?
They are the same. The epicenter is only the place where the fault started to move. It is not the location of the earthquake. The earthquake happens over the whole fault surface. And just like if I were going to try to tear this, I can't do this. What I would do is I'd start a tear here and then rip down this way. And this would be the epicenter, this would be the fault surface. The earthquake's happening over this whole fault. So we think that what's happening here is a fault about 25 miles long. We started at the end, the part that hadn't broken before the 7.1. Potentially it ruptured in both directions. About 80% of earthquakes are unilateral rupture in one direction, and about 20% rupture in both directions.
So on the 178, there was a left lateral slip of about 6 inches. Could we expect that to grow?
That's actually the left lateral one is down on the southwest striking fault. So down here, and it's not at all clear that.
So what it means is a little left lateral.
7.1.
So do you know what
Your
kind
left
of
hand, if
earthquake
you
it
had your
was?
hands
Yeah.
together,
What do you mean by kind
you're
of earthquake?
like
It's a strike
this.
slip. It's strike slip.
Your left
It's
hand
strike
would be
slip.
coming towards
That's
you, your
something
right
that we
hand would
can
be
get
going
from
away from you.
seismic records, and it's very clearly strike slip.
Yeah, and just to follow on with that, the event yesterday was left lateral strike slip, which actually released some compression on what we think is the fault that ruptured this evening in the 7.1. This event presumably is a right lateral strike slip. but basically motion horizontally. And again, with this magnitude and this length, the
I have to double
expectation of
check.
having
I want to
surface
say I
rupture
got
is
it
much,
right, but
much greater. And by being able to go out and actually measure that,
or I think left lateral
I'm trying to think
might
back
be
for landers,
left
there was
going
up
away
to,
from you, right,
I don't know,
coming
10
towards
feet
you,
of
right lateral, right
displacement.
going
18
away.
feet was the maximum
18.
It's been a
displacement
while.
in landers.
18 feet of displacement.
Meaning if the fault ran between you and me, right now we're looking at each other, after the earthquake, I would be 18 feet farther down there.
Yeah,
There was a school of thought a while ago that the seismicity of the state was moving straight up, as opposed to San Andreas. And you had Landers, you had Hector Mine, now you have this. Does this add to that academic debate?
Right, that debate was not on human timescales. That was saying we were moving over there in the next few million years.
but actually, let me turn that around a little bit. I think these events are a reminder that we can have earthquakes anywhere in Southern California. And on a human time frame, as Dr. Jones is explaining, an event like today's could occur in the LA Basin. It could occur down south in the San Diego area. That's just because we live in an area that has many, many active faults.
Right, but if you have an earthquake fault, an earthquake of 7.1 magnitude, 150 miles away from the major metropolitan area, and you suffer damage here, you're in big trouble.
Oh, was there damage in the Los Angeles area?
My point is, we get calls, we ask for it, and there's a report of a power outage or somewhere. The region has to sustain a 7.1, 150 miles away.
Oh, absolutely. And I think for the most part, the region has. I think the incidences are probably somewhat isolated. I would be very surprised if there was much widespread impact in the Los Angeles area. But clearly up near the epicentral region, the Ridgecrest area, those folks are having to deal with a lot right now. We haven't gotten any direct reports here, but I'm sure there's lots of damage, and they are probably dealing with aftershocks as well.
And we're going to hear from your geologists. What information will they provide?
Well, they're going to be out in the field as soon as they can and as best they can. Obviously, it's nighttime right now. They may be limited. This is the Naval Air Weapons Station. Okay, so there's unexploded ordnance issues. They may not be able to get out there at night. When they get out there, they'll have to be escorted. That all those logistics are something they're going to determine.
But what they're looking for is finding a fault where we find that motion that's happened. Because we are seeing, with our seismometers, we see these waves coming off of here, and we calculate back they're probably coming off of the surface. When we get those field geology, it's like this fault has moved. And so it's ground truth.
We know that the
And
Navy's
what was
testing
examined
conditions out there. Is there any chance at all
No.
that anything underground from the Navy may have triggered any of this?
No. Look at
People
we've set
always
off
ask
pretty
that.
large nuclear blasts without ever setting off an earthquake. The largest earthquake, I think, set off by the largest nuclear blast was like a magnitude 2.
And the hypocenter for this one is down at 10 miles beneath the surface.
Is there anything about this earthquake that's surprising at all to you?
The size.
Well, no, in a way. I mean, as Dr. Jones was explaining yesterday after the 6.4, there was a possibility of having a larger event. And sure enough, we did. And, the mechanics of these two faults, the conjugate faulting, actually makes a lot of sense from a geologic or scientific perspective. So I would say no, there's not really any surprises that we've seen so far. Well, hopefully, number one, learn a little bit more about how earthquakes work. Number two, I think, there's teams out there looking at damage, how buildings responded. Every earthquake is a chance to learn what worked, what didn't work, and make improvements.
And obviously a better understanding of earthquake triggering. Hopefully we'll be able within this, because we have, I can go and rattle off all these previous earthquakes where we've seen one trigger the other. The recordings we have of those earthquakes are primitive compared to what we have now, and we don't really know all of what the mechanisms were in this earthquake. With the system that we put in place to do early warning, we now have hundreds and hundreds of stations that are out there giving us much clearer pictures of what's going on the fault. So now we're going to be able to see with much greater resolution than we've had in the past, what part of which fault moved and how did the pattern progress, and of course there's always the hope that we'll find something that's different about the foreshocks.
Yeah, and let me just
But
add.
we haven't.
Let me just add, in terms of learning, the shake alert system, which has been put in place in the last few years,